So today, guys, we're going to be working on the Unit 3 triangles review, okay? So remember, we have been talking about triangle congruency and all of that information. So starting up on the top left with our first question, identify each triangle based on sides. Equilateral, remember, is when we have a triangle with 3 congruent sides. Okay, isosceles is a triangle with 2 congruent sides. And then scalene, our triangle has no congruent sides. Okay, so all side lengths will be different. So looking at question number 1, we have 2 yards, 2 yards, and 2 yards. Well, all 3 side lengths are the same. So when we have 3 congruent sides, we're going to have an equilateral triangle. Looking at question number 2, we have 3 inches, 5 inches, and 7 inches. So since none of our side lengths are the same or congruent, this is a scalene triangle. Next one, in the diagram, RST is congruent to triangle XYZ. We need to find the value of X. So first off, which part is X on? Okay, so we have X right here, which corresponds to side RT, okay? And then we also have an X over here on side XZ. So what do I need to do in order to solve for X? Thinking about my congruent statement, I know that RT, so RT is congruent to XZ. They are corresponding sides, okay? Knowing that they correspond, I can say that RT equals XZ, okay? And then all I have to do now is just substitute in for my side lengths. So RT, right, RT here is X plus 21, okay, so X plus 21. And then XZ we see is 2X minus 14. Right? So now all we have to do is get X by itself, solve for X. Remember, to do that, we have to get X on the same side. Okay, so that leaves us with 21 equals X minus 14. And then after that, we add 14 to both sides. So X is a value of 35. Alright, so for the next one, we need to find the value of X. Alright, so here it is. X is right here. Okay, so this is going to have quite a few parts to it. Alright, so to find X, we're actually going to have to kind of work backwards. Alright, and I'm going to explain it as we go along and label the steps. Alright, so we know that X is right here in this narrow angle. In order to find X, I have to know how many degrees are in the full triangle. Okay, so a full triangle, remember, is 180 degrees. So if I know it's 180, I would need to know what these other 2 angle measurements are. I don't know these yet, but I know I have an isosceles triangle. And remember, an isosceles triangle, the angles opposite your congruent sides are congruent as well. So, because I have 2 congruent sides, the angles at the base are congruent also. I'm going to call these angle Z, because I'm going to have to figure out what this is. Okay? So, in order to find out what Z is, I have to know, okay, well, Z is in this corner, and then this is 72, but then what about this? How am I going to figure out Z if I don't know what this piece is? Right? So this is when we're going to say, okay, I know a straight line is also 180 degrees. Okay? So if I take this angle, Y, and add it to these angles, then I can get my missing angle here. Right? So just keep following along. It's piece by piece. right? So this angle y here, how am I going to figure out what this is? Well, I don't know. Let me look at my triangle. I have a triangle with two congruent sides again. So this angle up here is already being used. But remember, like we did earlier, when we have two congruent sides, the opposite angles are congruent also. So what we have to do, step one, we need to solve for y. Okay, 1. Solve for y. Step 2, after we solve for y, we have to solve for z. Solve for z. And then last, our ultimate goal, solve for x. Okay, so I know it's a few steps, but you guys are going to see a question like this somewhat tomorrow. So I want to make sure that we are thinking through this critically. Okay, so step 1, solve for y. How are we going to do that? I know that an entire triangle is 180 degrees. Okay, so I can say 180 equals, and again we'll label this 1. Okay, so step 1. 180 equals the total of all three angles added together. So these two plus this one. I'm going to say 2y, because we have two congruent y angles, plus 116. All right? So once we get to this point, we subtract 116 from both sides. We're going to get 2y equals 64. Right? And then when we divide by 2, we're left with y equaling 32. Okay? So y equals 32 degrees. So I'm going to put this right here. Okay? Knowing that y equals 32 degrees, I can now solve for z. Okay? So remember earlier we said straight line? If a straight line is 180 degrees, and I know that my adjacent angles are going to add to 180, just like we did here, I can add my angles to find my missing z value. All right? So step 2, solve for z. I know that the measure of angle y plus the 72 that's already there, plus the z that I need to solve for, my z's look like 2's, I'm sorry guys, is going to have to equal 180, because all three of these angles together are supplementary, right? They add to 180. So knowing what we know about y, we're going to substitute that in. So 32 plus 72, and then we still have to solve for z equals 180. Okay, so 32 and 72, we get 104. Okay, and then to get z by itself, because again we're looking for this angle here, we have to subtract 104 from both sides. So z is going to be a total of 76. So z equals 76. All right, so step 2 is done. All right, so I'm going to fill that into my triangle. So I know if these two angles are congruent, then the angle measurements will be the same. So step 3, we have to solve for x. We know that x plus 2z is going to equal 180 total degrees. Oh, that's supposed to be a z. 2z. Okay? X plus these two z angles equals 180. So I know x plus 2 times 76. All right. That's going to leave me with x plus 152. Right, and then when I subtract that, I'm left with x equaling a total of 28 degrees. Okay, so moving on to our next problem. All right, we have to classify TJD. Remember, classifying is based on sides, so equilateral, isosceles, or scalene. Okay, TJD, we need to find the lengths between each side. So, how do we find the length of the distance between 2 points? All right, remember, dang it, our distance formula. Okay, so again, use our distance formula. We're going to have to plug in each point to find how long the sides are. So we're going to start with side TJ. Okay, so I plug it in here. So since I'm starting at I'm starting at T, so that'll be my 1s, J will be my 2s. All right, so we have x2 minus x1. Remember, minus a negative, you have to add. Okay, and then y2 minus y1, which again, minus a negative. So for side length TJ, we get a total of 8.06. All right. So we did that for our first side. Now we need to do it for the other 2 sides as well. My next side would be JD. So just like we did before, set up our problem. JD, we're going to have 1 minus 0 plus negative 1 minus 5. We're going to get that JD equals a total of 6.08. We know it's not equilateral, because remember that has to have 3 congruent sides. So far, we're not on that track. But we still have one more side to figure out. So last side length, DT. Okay? So side length DT, we're going to have negative 4 minus 1. And then negative 2 plus 1, because minus a negative. DT is 5.09. All right? So now compare all 3 side lengths. We have about 8, about 6, and about 5. Okay. We do not have any congruent sides. So we can say that since no sides are congruent, triangle TJD has to be scaling. Okay? So moving on, we need to determine which postulate or theorem can be used to prove each pair of triangles congruent. Right? If it's not possible, we're going to write not possible. Remember, we went over this yesterday, so we're going to go a little quickly today because it still should be fresh on your mind. Okay, so for this first triangle, I'm told I have a set of congruent angles between these, another set of congruent angles here, and then we also, right here, remember, have this shared side. Okay, so a shared side is reflexive, which means it's congruent between both triangles. Okay, so for this example, we have a congruent angle, a congruent shared side, and then another congruent angle. Okay, so by ASA, we can determine that both of these triangles are congruent. Angle, side, angle. Right. Sorry, I'll close Desmos out too. Go away. Minimize. Okay, there we go. Now you can see more. Okay, so moving to the right to the next problem, we have 2 triangles that make a rectangle. Okay, so we have congruent bases there, another set of congruent bases here, and then again a shared side, so those are automatically congruent. Looking at it, we have a side, another side, and a third side that's congruent. Okay, so by side, 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 we can determine that both of these triangles are congruent. Okay. Looking at this one, we have, it looks like two isosceles triangles, but let's see what we got. Okay, so we have this one up here. The two sides are congruent just in that triangle. This triangle has two congruent sides as well, but what do we notice? They're not sharing any of those congruencies yet. Okay? The only thing that is congruent among both triangles is this third side right here. Since we only have one congruent side, we cannot determine if these are both congruent. Okay, so it's not possible. We don't have enough information. All right. Last one. Congruent sides. We're shown these angles are congruent. And then again, a shared reflexive side. So we can say side, angle, side in order. The A is in the middle because it is joining those two congruent sides together. SAS. Okay, two more. Almost there. Find the length of the missing side. All right, remember, anytime we have a right triangle and we have a missing side, we can use, you guessed it, the Pythagorean theorem. Okay, where C is our hypotenuse, right? The side opposite our right angle. Okay, so in order to find x, in this case, the hypotenuse, we're just going to substitute in the values that we are given. Okay, so A we'll say is 9, B is 12, C is x. Okay, simplify that straight out. So we get 81 plus 144. Right, adding 81 and 144, we get 225 equals x squared. Okay, and then remember we are solving for just the x, so we need to get that by itself. Take the square root, and we're left with x equals 15. Okay, last one, the proof. Okay, two-column proof. This one, I promise, is not bad. Okay, so statements and reasons. Okay, so statements, always start with your given information. So PQ bisects angle RPS. Okay, so we're going to doodle that out a little bit. We have RPS right here. Okay, and it's being bisected by PQ. Also, we are told that angle R is congruent to angle S. So again, I'm going to label that on my triangle. R and S are congruent. Why did I write these down? Remember, always start with your givens. Okay, so reason number one, it's given to me. Okay, so now we're going to move on to the next step. Okay, so I have a angle per my given information that's bisected. All right, remember, anytime you have something, an angle that's bisected, it is cut in half. So if it's cut in half, we know that each side, each part is congruent. Okay, so angle RPS, this angle here, has to be congruent to angle SPQ. Okay, again, the reason why, it's being bisected. Definition of bisect. Okay, bisected angles are congruent. Okay, next we're going to say, okay, what else do I know? Well, I have PQ right here, right? I notice that it's a shared side between two triangles. Right? Remember, shared sides are congruent to each other, or in another word, reflexive. So PQ for this triangle has to equal PQ for this triangle, right? And that is because of our reflexive property. Okay, reflexive property. So that's all the information I can decipher out of my triangle. Now I need to say, okay, how do I know RPQ is congruent to triangle SPQ? Well, let's see what I have. I have congruent angles in both. I have another set of congruent angles in both. And then I have a shared side that's off on its own. So I can say, for certainty, triangle RPQ is going to be congruent to SPQ because of my AAS. Alright? Again, AAS because the S is not included with those two angles.